Hi, my name is Rivera. I'm the Director of Scientific Outreach here at Meter Group, and today we're here to talk about particle size analysis measurements, and we're going to focus on the basics behind the measurement. So before we get into the measurements themselves, it's really important to think about the importance of the particle size distribution of soils and why we even want to make this measurement. And one of those primary reasons is that the particle size distribution of soils is a fundamental soil physical property. And it impacts so many different things. It impacts the soil's ability to retain water. It impacts our hydraulic conductivity of soil, how water and nutrients leach through the soil. It impacts the erosion potential of soil, plant nutrient storage dynamics, and especially things like organic matter dynamics and how that changes because soil texture can play a really big role there, and the carbon sequestration capacity of soils. And typically in the US, we think of the soil as being kind of a function of this triangle that you see here. This is the US Soil Taxonomy textural triangle. And typically we're breaking it up into different classes of soil based on the sand, silt, and clay fraction. And so as we're thinking about that, it's really important to think, what makes up particle size distribution? What is it that we're actually looking at? And so when we break this down, what it is, we're primarily looking at the mineral components of soil, and we're trying to figure out what is the breakdown in terms of a percentage of, based on weight, of the sand fraction, which is the 0.05 to 2 millimeter size soil minerals, the silt fraction, which is the 0.02 to 0.05, and then our clay fraction, which is anything less than 0.02 millimeters. And that percentage breakdown is really important, and that's what really governs, of course, what our soil texture is, but really governs a lot of these properties. Traditionally, when we're trying to make these measurements to figure out what our sand, silt, and clay fractions are, these are some of the tools that we would normally use to make these measurements. The first most basic tool for doing this measurement is hand texturing. And if anybody's ever done this before, you know that you're taking a small wet clod of soil and feathering it out, and you're trying to estimate how much sand, silt, and clay is in that soil by hand. As you can imagine, this is a very crude method. It's not very accurate, but it's a tool that we use in the field when trying to quickly assess what the soil is that we're working with. The other actual measurements of particle size analysis or soil texture are done using tools like sieving, where we're going to sieve out the different sizes of soil particles using either dry or wet sieving. And then typically that's combined with something like one of our sedimentation methods, which we'll get into a little more about the physics there, but that are based on Stokes' law. And that's typically either the hydrometer or pipette method. And then some of the newer methods that we've also have seen come into use include the optical methods like X-ray attenuation, laser diffraction, and visible near-infrared spectroscopy. We're primarily just going to focus on the laser diffraction today, but there are other methods for making these measurements optically as well. An important thing to think about when we're making these measurements is what is the actual classification system that we're trying to base our measurements on. So we have the USDA soil classification system, but there's also some ASTM standard methods that is more so used on the engineering side. You have the Unified Soil Classification System. The Germans have their own classification system. So as we're making these measurements, it's important to also think about what is the actual classification system that we're using, because as you can see here, that breaks down different sizes for what they call different minerals that we have to think about when making these measurements. So again, it's important to think about the application that you're actually trying to use these measurements for, and use that as your guiding light for what measurement is going to work best for you, because not every measurement method is going to work best for each application. And sometimes one might be overkill versus another. So think about this when it comes to what measurement you're thinking about using and which measurement method will work best for you. Some other fundamental pieces behind the measurement that's really important to think about is how are you trying to portray the data that you're measuring. So oftentimes when we're thinking about particle size analysis measurements, the measurements are typically given either in terms of soil texture or your sand, just your basic breakdown of your sand, silt, and clay fraction. But also sometimes we're trying to actually look at the particle size distribution curve like you see here. And there are advantages to both. Of course, just basic soil texture is super simple and really easy to portray, but there are some components that you can get out of the particle size distribution curve that are helpful when understanding what the actual breakdown of the sand, silt, and clay fraction and as those sizes change, what that actually might mean in terms of some of these soil mechanics and the behavior that you're going to see in terms of hydraulic properties and all of these things that you might see in soil. And then one last piece to think about is the soil handling that you have to go through when making these measurements. Almost all of these measurement methods, minus some of the optical methods, there's some prep that has to be done to the soil before making the measurements. And this involves dispersing the soil into individual primary particles. So typically we use a chemical and physical dispersant. Oftentimes we have to remove organic matter from the soil to make this measurement. And in some cases, we're going to have to do iron oxide and carbonate remover from the soil. Those are rarer, but these are things that you're going to have to think about because these might impact your ability to make these measurements depending on the method you choose. So before we get a little bit deeper, it's really important to understand some of the physics behind this measurement and what we're doing. And one of the most common measurement methods for doing particle size analysis are based on Stokes' law. So the sedimentation methods involve taking an aqueous suspension in a cylinder, and you can kind of see some examples of that here. And after homogenizing the particles, essentially that means getting the particles on suspension equally, what we're doing is measuring the settling velocity of that solution. And that all depends strongly on the size of the particles that are in suspension. The larger particles fall out faster, your sands. Your finer particles like the clays are going to stay in suspension longer, and in some cases indefinitely. And Stokes' law relates that settling time of the size of the particles that remain in suspension. And that's how most of these measurement methods are working to figure out what is actually remaining in suspension at different time intervals. And we'll talk more about those methods and how they work in a future video.